Now, another problem I want to go over is what happens if you cannot factor a trigonometric equation. So here we have kind of in basic algebra, whenever you have, we know the zero factor property only applies when we have a product that's equal to 0. Well, in this case, on the left side it appears to be factored because we have a product, cosine x times cosine x plus 2, but that is not equal to 0, so we can't use this property. So whenever that happens, what you have to do is you have to multiply everything out and then set it to 0. So in this case, if I distribute, I get cosine squared x plus 2 cosine x equals 1. Alright, now I'm going to set it to 0. So cosine squared x plus 2 cosine x minus 1 equals 0. Now, I know it's not going to factor because if you think about how factoring works, factoring is just pretty much reverse foiling. So imagine, if I'm trying to figure out what multiplied out to this, the only way we can get cosine squared is if we have cosine x, right? Because then when you FOIL, you would get cosine times cosine. That would give you cosine squared. And then the other thing that you do is you try to figure out the different ways when you're reverse foiling or factoring. You try to figure out the different ways that you can get this constant here, because those factors, the numbers that multiply to that, end up being the numbers that you use over here. Well, the only way to get negative 1 using integers is if you have either plus 1 or minus 1. And notice here that it's not going to quite work that way. We do get the negative 1 that we want, but then also we have 2 conjugates now. See, these are now conjugates. And we know that when we have conjugates that this will FOIL out to cosine squared x minus 1 when you multiply everything out. When you FOIL cosine times cosine is negative 1, 1 times cosine, 1 times negative 1. The middle term cancels, you get this. And it doesn't even matter if you move this as a minus 1 and a plus 1, you would just still have conjugates and it would still multiply out to this. So the point being that this will not factor. Well, if it doesn't factor, you don't give up. What you do is you apply the quadratic formula. And just to make it look a little bit easier, you can use a substitution, so you can let u equal cosine x. That way the equation now is u squared plus 2u minus 1 equals 0. Now you can apply the quadratic formula like you normally would. So quadratic formula states that the solutions to this will have the form u equals negative b, so in this case negative 2, plus or minus the square root of b squared, so 2 squared minus 4 times ac, so 1 times negative 1, all over 2 times a, so 2 times 1, so 2. So simplifying, we get u equals negative 2 plus or minus the square root. This is 4 plus 4, 8, all over 2. So u will be negative 2 plus or minus. Simplifying this, we can factor out a 4 out of that. So we take the 4 out, becomes 2. So 2 root 2 over 2, which will be, now dividing the 2 into here, both of those 2, we get negative 1 plus or minus root 2. All right. So now, replacing u with cosine, we get cosine x now is equal to negative 1 plus root 2, or cosine of x is equal to negative 1 minus root 2. Okay, so punching, just getting a approximation here. This will be approximately 0.41. And this will be approximately negative 1.41. So it turns out that this one will not yield any solutions because oops, I apologize. I think it should be, I have this wrong. I think it should be 2.41. Apologize. Yes, negative 2.41. Anyway, as I was saying, recall that for y equals cosine x, that the value of y always must be between negative 1 and 1. Remember, we call that the range. So the range of cosine is negative 1 to 1. So negative 2.41 is not in the range. So this is not possible because negative 2.41 we say is not in the range of cosine. Therefore, we only have to focus on this equation here. We need to find the values of x that will work here. So now what you do is, because this is 0.41, positive value, we know that the solutions for x are going to be in quadrants 1 or 4, because that's where cosine is positive. Now we need to find the reference angle, and to do this, what you do is you take the inverse, because this is not a common ratio, we need to use our inverse function to find the reference angle. And so you're just going to do cosine inverse of negative 1 plus root 2. Now the one thing I want to point out is, let's suppose this were a negative 0.41, then, or if you had a negative expression, what you would do is you would take cosine inverse, especially if you want to use the exact value, you're going to do cosine inverse, and then you're going to place a negative on the outside. So maybe, and I'll erase this in a second, but you would have a negative like that. Let's just say if this were negative. Yes, because when you want to find the inverse, the reference angle using the inverse function, you want this value to always be positive. And when we study inverse trigonometric functions, you'll understand why. But right now, anytime this is a negative value, and you want to find the reference, you take the inverse of the positive of that, or the opposite of that. So you put a negative on the outside, that negative will now switch this to a positive, and then now you're taking the inverse of a positive value. Right. So if you already know it's positive, then there's no need to do that, of course, like in this case. So we're just going to go ahead and erase. Oh, that's not what I wanted to do, but oh well. All right. So we take the inverse of that, and we find that the reference angle is and then you want to make sure that you're in radian mode. Okay, I just had to switch mine. And so what I get here, this is approximately 1.14, approximately. So that's our reference here. So that's 1.41. Oops, sorry, 1.14. And then so is this. So one of the answers is x equals 1.14. And then the other one is going to be, if this is 2 pi, then the other one's going to be 2 pi minus 1.14. And then when I do that, I get 5.14 approximately. All right, and then those would be your two solutions here.